Beyond the orbit of Pluto, in the cold, dark reaches of our solar system, lies an enigmatic and largely unexplored frontier, the Kuiper Belt, a vast, icy region filled with countless objects, some of which hold secrets about the early solar system itself. It is a place where the mysteries of our cosmic origins begin to unfold, and where the unexpected thrives. Imagine a world beyond our familiar planets, where the sun is a faint, distant light, and the darkness of space stretches in every direction. This is where the Kuiper Belt resides, an area that, until relatively recently, was nothing more than a theoretical boundary. Now, it's an area of intense fascination, with every icy rock, dwarf planet, and comet adding another layer to the story of our solar system's birth. Stretching from just beyond the orbit of Neptune, the Kuiper Belt extends out to a staggering 50 astronomical units from the Sun. 1 astronomical unit, or AU, is the average distance from the Earth to the Sun. To put this in perspective, the Kuiper Belt spans a region larger than the space occupied by all the planets combined. This vast area, though far less explored than the inner solar system, is far from empty. It is a region teeming with icy objects, remnants from the early solar system, many of which are as ancient as the Sun itself. These objects have remained largely untouched, their surfaces frozen in time, preserving crucial clues about how our solar system came to be. At the heart of the Kuiper Belt is Pluto, once the 9th planet and now classified as a dwarf planet. Though often overshadowed by its former status, Pluto remains a fascinating and important piece of the puzzle. But Pluto is just one member of a larger, even more diverse family of icy bodies scattered across the belt. In addition to Pluto, the Kuiper Belt is home to a variety of other dwarf planets such as Haumea, a strange and elongated world whose shape has been altered by its rapid rotation, and Makemake, which stands out for its mysterious lack of atmosphere. Then there is Eris, a massive object nearly as large as Pluto, and once thought to be the solar system's largest dwarf planet before the discovery of more distant bodies. These objects are not just distant worlds, they are remnants of the building blocks of the solar system. Each one carries a history, a signature of the conditions that existed in the distant past when the solar system was still forming. As we explore these distant bodies, we uncover more about the forces that shaped the planets, and perhaps even the conditions that led to the development of life here on Earth. To understand the importance of the Kuiper Belt, we must first journey back in time to the solar system's infancy. Some 4.6 billion years ago, the solar system formed from a giant cloud of gas and dust. As the sun ignited at its core, the planets began to take shape from the remaining material. In the inner solar system, heat from the sun caused metals and rocks to form solid planets, while in the cooler, outer regions, ices and gases remained frozen, forming the building blocks of the Kuiper Belt. These objects in the belt are what we call planetary embryos, small, icy bodies that never coalesced into full-fledged planets. Instead, they were left behind as frozen relics of the early solar system, preserving the chemical composition and environmental conditions of that formative period. By studying the Kuiper Belt, we are peering into a time when the planets were still young, when the solar system was a chaotic and volatile place. And in many ways, the Kuiper Belt is a time capsule holding crucial evidence about the processes that led to the formation of not just our solar system, but potentially other star systems across the galaxy. In 2015, humanity took a giant leap forward in its understanding of the Kuiper Belt with the historic flyby of Pluto by NASA's New Horizons spacecraft. This mission, which had already made history by traveling farther from Earth than any other spacecraft in history, provided the first detailed images of Pluto and its moons. But it didn't stop there. New Horizons continued on its journey beyond Pluto, into the unexplored depths of the Kuiper Belt, heading toward a small, icy object known as Arrokoth, the most distant object ever visited by a spacecraft. Its peculiar, two-lobed shape, a contact binary, offered scientists a rare glimpse into the processes that might have formed these icy worlds. Arrokoth, like many of the objects in the belt, had been largely untouched by the sun's warmth, making it an incredibly valuable window into the early days of the solar system. Arrokoth, named after a word in the Powhatan Native American language meaning sky, is a cosmic relic, a frozen snapshot of the solar system's formation. Its reddish surface, a sign of the complex organic molecules that have accumulated over billions of years, hints at the chemical building blocks that could have played a role in the origins of life. In a sense, Arrokoth is a direct link to the ancient past, offering a rare chance to study the raw materials that might have contributed to the emergence of life on Earth. These organic molecules, known as tholins, are thought to be the precursors to more complex compounds, possibly even the very molecules that gave rise to life itself. As we study objects like Arrokoth, we not only learn about the solar system's history, we are also unraveling the very story of life's origins. While Pluto is the most famous object in the Kuiper Belt, it is just one among many. The Kuiper Belt is an expansive and diverse region, home to thousands, possibly even hundreds of thousands, of icy bodies, some of which are too small or too faint for current telescopes to detect. These objects include dwarf planets, comets, and countless smaller bodies that continue to intrigue scientists. Each of these objects offers a potential breakthrough in our understanding of the solar system's formation. What's more, many of these objects are on eccentric orbits, meaning they are constantly moving through the Kuiper Belt, offering astronomers new opportunities to study them in detail. With the right technology, future missions could unearth even more incredible discoveries, revealing hidden treasures in this cold, distant region. The Kuiper Belt is also home to many comets, some of which originate in this icy region before traveling closer to the Sun. When comets approach the inner solar system, the heat of the Sun causes their icy cores to vaporize, forming spectacular tails that stretch across the sky. These comets are some of the oldest objects in the solar system, and their composition can provide clues about the chemical makeup of the early solar system. By studying comets from the Kuiper Belt, we learn about the volatile materials, such as water, ammonia, and methane, that were present in the early solar system and may have contributed to the development of life on Earth. Beyond the Kuiper Belt lies the Oort cloud, a mysterious, far-flung region that is thought to be the origin of long-period comets. Though its existence has never been directly confirmed, the Oort cloud is believed to be a vast, spherical cloud of icy bodies surrounding the solar system, stretching out to almost 1 light-year away. It is thought to be the ultimate source of many comets that make spectacular journeys toward the Sun. Together, the Kuiper Belt and Oort cloud represent the outermost regions of our solar system, a mysterious realm where icy worlds and comets hold the keys to understanding the cosmic forces that shaped our solar system. As we look to the future, missions to the Kuiper Belt will continue to push the boundaries of space exploration. The James Webb Space Telescope is already providing unprecedented views of distant objects, and new spacecraft will follow in the footsteps of New Horizons, venturing even further into the icy frontier. These missions promise to unlock more secrets of the Kuiper Belt and beyond, secrets that could help us understand not just the origins of our solar system, but the conditions necessary for life to form elsewhere in the universe. The Kuiper Belt is a treasure trove of ancient knowledge, a frozen archive that holds the answers to questions we've only just begun to ask. It is a reminder that the solar system is far more mysterious than we ever imagined, and that the universe still has many secrets to reveal.